Hello folks, this is your notes video on the interior and exterior angles in polygons. So I'm just going to go ahead and jump right into it here. So just as a quick reminder for you, when I'm talking about a polygon is just any closed geometric figure. It's our fancy name for a shape. Okay? Angles that are inside of a polygon are called interior angles. Shocker. Okay. In a regular polygon, we have shapes, right? Regular polygons are shapes that are both equilateral, meaning all of the sides are the same, and equiangular, meaning all of the angles are the same. Okay, so you can see a bunch of regular polygons on the screen right here, right? And each one of them gives you the sum of all of the interior angles in those polygons, right? So for example, on this heptagon right here, right, the sum of those 7 angles right there is 900 degrees, right? Which means that one of those angles is 900 divided by 7, okay? We have this formula that we can use to calculate both this number right here, the sum of all of the angles in a polygon, as well as the measure of one angle in a regular polygon. Okay, so I'm going to show you quickly kind of how that works, or why the formula works the way that it does. So I'm just going to draw a random 5-sided figure. So there's a 5-sided figure. Here's a random 6-sided figure. Okay, so here's where this formula for the sum of the interior angles in any polygon comes from. Okay, you can take any polygon, even the ones that are very badly drawn on the screen by me right here, and divide them up into triangles by connecting their vertices, but without having any of those lines cross. So for example, in this shape here, right, this 5-sided shape, I can draw a line here, and I can draw a line, not very well, obviously. I can draw a line here. Okay, so I have 3 triangles in this shape. Okay, in my 6-sided shape, I can do something very similar. So I can say draw a line here, I can draw a line here, and I can draw a line here. So there's 4 triangles in this shape, right? 6 sides in this shape. There's 5 sides in this shape. Okay, so if I wanted to find the sum of all of the angles, right, in this 5-sided shape, right, that's this angle, which you can see is made up of this smaller angle in this top triangle, and this angle in this middle triangle. There's this angle, and this angle, which is made up of 3 different angles in these triangles, right? So if there's 3 triangles, right, and each one of them has 180 degrees in it, right, I can find the sum by doing 180 times the number of triangles. Okay, and the cool thing about this is the number of triangles is always going to be the number of sides minus 2. Okay, so that's where we get this formula right here. Okay, so any polygon with n sides has the sum of all the angles in that polygon is the number of sides n minus 2 times 180. N minus 2 is the number of triangles. Okay, now in a regular polygon, all of the angles, all of the interior angles will be equal to each other. So we can take the sum, which is right here, the sum of all the angles, and divide by the number of angles there are. Okay, so that's why you have this slightly more complex formula for the measure of each individual angle in a regular polygon. Okay, which is kind of what's going on in all of these parts of this this thing that you see on the screen right here, where they're calculating one angle for each of these, right? Taking the sum and dividing it by the number of angles, the number of sides. Okay, so I'm going to clear my screen here, right, and actually write what these equations are. Okay, so the sum of all of the interior angles is 180 times n minus 2. Okay, where again, n is the number of sides. Okay, and then for regular n-gons or regular polygons, you take the sum, 180 times n minus 2, divided by the number of sides that you have, the number of angles that you have, which is n. Okay, and you're going to see in the practice problems video that you can use these equations going both ways, right? So technically what I have here is this equation, 180 times n minus 2 equals the sum, right? This equation is technically 180 times n minus 2 divided by n equals each angle. Okay. All right, so that's interior angles, okay? And then there is a separate rule for exterior angles, okay? These are a little bit less common, but they do show up every once in a while. So an exterior angle is exactly what it sounds like. So if you take any polygon and extend, right, and extend the sides, right, you'll have an interior angle paired with an exterior angle. And those two together are always going to form a straight line, right? So your interior and your exterior angles, right, your interior plus your exterior is going to equal 180, right? They're all going to make a straight line, which you can kind of see in these drawings here, right? If my interior angle is 60 and I extend that side out, my exterior angle is 120 because those add up to 180. You have 90 and 90 with the square. You have 108 and 72 with the pentagon, the regular pentagon, and so on and so forth. Okay? All right. So the rule here, the exterior angle rule, is that no matter what the polygon looks like, no matter how many sides it is, no matter how many angles it has, always the sum of all the exterior angles is going to equal 360 degrees. Always, always, always. Okay, which you can kind of see in this triangle on the right-hand side of the screen right here. Okay, I have my three exterior angles, 1, 2, and 3, and those are going to add up to 360 degrees. This works in all polygons as long as they're convex, meaning that they don't have a weird angle like this, where it looks like it's collapsed on itself. Okay. All right, so then if we're again talking about regular polygons, then that means the measure of each exterior angle in a regular polygon is 360 divided by n, right? Or the number of sides. Okay. Which again, you can kind of see in the angles up here. So for example, in this pentagon right here, if I want to find the measure of each exterior angle, I'm going to do 360 divided by the number of sides, which is 5. And that gives me 72, which is what you see in the actual drawing here. All right, so I want to do a couple of quick examples for you all here. And then there's another video that's a little bit longer that'll do some practice problems for you. Okay, so this one, right, is asking me to find, I'm actually going to switch it up a little bit. So let's say for the septagon, I want to find the sum of the interior angles. For the octagon, I want to find each interior angle. And for the decagon, I'm going to find each exterior angle. All right, so for a septagon has 7 sides, means n is equal to 7. Okay, so I'm going to write that a little bigger. Hold on. Okay, so for a septagon, I have n is equal to 7. Okay, so the sum of my interior angles is 180 times n, which is 7, minus 2. Okay, so that's 180 times 5, and 180 times 5 is 900 degrees. So that would be my final answer for that one. All right, then let's look at this one. So for an octagon, if I want to find each interior angle, remember an octagon has 8 sides, so n equals 8. Okay, so if I want to find each interior angle, my formula is 180 times n minus 2. Oops. Doing some craziness here. So 180 times n, which is 8, minus 2, divided by 8, divided by n. Okay, so this is 180 times 6 divided by 8. So 180 times 6 is 1080, and I'm going to divide that by 8, and that equals 135 degrees. So that would be my final answer for that one. All right, and then the last one here is a decagon. A decagon has 10 sides, right? Decade is 10 years, decagon 10 sides. Okay, so if I want to find the measure of each exterior angle, so each exterior angle, that's just 360 divided by n, which is 10. Right? And that's a pretty quick one. So 36 degrees would be my final answer. All right, you guys. So if you are feeling good about this concept, then you don't necessarily need to watch the practice problems video, but I'm going to do a fair number of examples for you in the practice problems video that work these formulas going both forwards and backwards. So if you are interested in watching that, that'll be the next video. Right? But I'll see you all in the next one. Bye, everybody.